Okay, derivation of rate law equation for the chain reaction. So this is the example from question 1. So in steam cracking, the homogeneous pyrolysis of ethane, so ethane C2H6, to produce ethylene C2H4 and hydrogen is carried out in a pipe heated to 850 degrees C at an ethane pressure of 1 atmosphere. The major reactions are thought to be, so the mechanism given as the given equations. There are 4 steps in the mechanisms of this reaction. Determine the order of the reaction with respect to ethane. So, meaning that you need to derive the rate law equation in terms of ethane concentration. So, dalam sebutan C2H6. So, first we need to determine the steps of reaction, which one is initiation, propagation and termination. So if you look at the mechanism, the first reaction is initiation because it produces C2H5 plus H. How we know that it is initiation step? So if you look at step 2 and step 3, the reaction produce the product. So therefore, the first reaction is the reaction that produce the intermediate product. Okay, so if you look at the mechanism, so we can compare the mechanism and the overall rate reaction. So if the reaction that not produce the product, so it is not the propagation. Okay, so you can label it, the first reaction, as initiation step. Okay, because it produced the two intermediate C2H5 plus H, and the second reaction, the intermediate C2H5, will produce the product C2H4 and another intermediate H. So second step is propagation step 1. And the third step, C2H6 reacted with another intermediate product H to produce C2H5. So intermediate C2H5 plus product H2. Therefore, the third step is propagation step 2. And the last steps is 2C2H5. We know that C2H5 is the intermediate product. So when intermediate reacted with the intermediate to produce side product C4H10. So the last one is the fourth step is termination step. Right. Then we need to write the rate law equation for each step. So for step 1, you can write the rate law as R1. Okay? So you can write, because based on the rate constant given, K1, K2, K3, K4. So the first reaction is R1 equal to K1 concentration of C2H6. Then step 2, R2 equal to K2 concentration of C2H5. Similar for step 3. Step 3, R3 equal to K3 concentration of C2H6 concentration of H. And step 4, R4 equal to K4 C2H5 power of 2, because the stoichiometric coefficient in the last step is 2. So power of 2. Okay. Then after that, determine which step is the overall rate. So in this case, kita ada 2 propagation step, but the major product is ethylene. Okay, because from the question, the pyrolysis of ethane to produce ethylene. So the major product comes from reaction in step 2 or propagation step 1. Okay, therefore the overall rate R equal to R2, which is equal to K2 C2 H5. Okay, but concentration of C2H5 is in terms of intermediate product. So the intermediate will have very low concentration and unstable species. So we want to eliminate the term C2H5. Okay. Next, we need to write the mass balance of intermediate. So how many intermediate that we have? We have C2H5 and hydrogen. So write the mass balance. So mass balance of intermediate or radical. So we have C2H5 and hydrogen. So we need to write one by one. After that, apply PSSH. Okay, mass balance of C2H5. So look into the mechanism of reaction. C2H5 involved in step 1. So in step 1, C2H5 appear. So let's say the reaction assume in the PFR, because it's not stated in the question, either it is in PFR, batch or CSTR. So the easiest mass balance is for PFR. So let's say reaction in PFR. So D C2H5 per dt equal to, so in the first steps of reaction, C2H5 appear. So it will be positive K1 C2H6. Okay, then in step 2, C2H5 disappear. So minus K2 concentration of C2H5. And then in step 3, what happened in step 3? C2H5 form. Okay, so plus K3 plus K3 C2H6H. And then in step 4, C2H5 disappear. So kalau disappear, minus 2K4 C2H5 square. So this is the mass balance equation for C2H5. Okay, then you can label the equation as equation 1. Okay, next we write the mass balance for intermediate H. Okay, mass balance of H. So dH per dt. Okay, look at the mechanism. The first reaction, H form. So K1 C2 H6. In reaction step 2, again H form. So plus K2 C2 H5. In reaction 3, H disappear. So minus K3 C2 H6 H. And step 4, intermediate H not involved. So this is your mass balance for species H, and we can label it as equation 2. Okay, next kita apply PSS approximation. Okay, apply PSS for the radical species or intermediate product. D C2H5 per dt equal to 0, and dH per dt also equal to 0. Then we will get equation 1 and equation 2 will equal to 0. Right, so both equation 1 and equation 2 equal to 0. So we get the simultaneous equation for equation 1 and 2. So we can solve the simultaneous equation here by adding equation 2 with equation 1. So add equation 2 with equation 1. Okay, because both is the simultaneous equation. So we can solve these two equations. Then you will get 2K1 C2 H6 minus 2K4 C2 H5 square, which is equal to 0. Okay, then rearrange the equation. Okay, rearrange for C2H5, because remember our objective is to eliminate terms C2H4 in the overall rate law equation. So that's why we need to determine what is the concentration of C2H5. So C2H5 square equal to K1 per K4 C2H6. Then C2H5 equal to K1 over K4. So solvekan. Bracket, don't forget about the bracket. So C2H6 power of half. Okay, then insert this equation into the overall rate. So overall rate R equal to R2 K2 C2 H5 tadi. So R equal to K2 K1 over K4 power of half C2H6 power of half. So the order of reaction is 0.5. So based on this overall rate law equation, order of reaction equal to 0.5 because C2H6 is power of half. So this is the rate reaction with respect to ethane.